to my YouTube channel at the OK Zone. This channel is an edutainment channel, more of educational content and entertainment content. Now today I'll be treating a question on electrolysis. Friday's law, first law, second law. We're going to start up with just the first law. So briefly on the board, we have a question here. It says what mass of magnesium would be obtained by passing a current of 2 amperes for 2 hours 30 minutes through molten magnesium chloride? And we are given that 1 Faraday is equal to 96500 coulombs. Magnesium given to us as what? 24. Now we are asked to find the mass of magnesium. To find the mass of magnesium that will be obtained by passing a current of 2 amperes for 2 hours. Now what it means is that this is a process taking place, and what process is that? Electrolysis, you understand? So now we're asked to look for the mass of magnesium that will be obtained when a current of 2 amperes for 22 hours 30 minutes passes through the molten magnesium chloride. Now what do we do first of all? Like I said, to solve a question like this, we need to identify what the variables there. So we have current given to us. So take up solution. So we have current, that's I, and note current is measured in amperes, so 2 amperes, that's 2 amperes. Then we also have time given to us as what? 2 hours 30 minutes. Okay, 2 hours 30 minutes. And also we have Faraday, we have, yes, already given to us. So what do we do first of all? Looking at this, we know that current is measured in what? Amperes, and time is measured in what? Seconds. Take note, time is measured in seconds. Time is measured in seconds. Okay, so what do we do now? We have to convert these 2 hours 30 minutes to what? Seconds. Now what do we do? Now for us to convert these 2 hours 30 minutes, we're going to write out hours. So it's going to be 2 times 60 times 60. Okay, that's for this one first. Let's get it. Then for this one, we're going to be plus. To convert minutes, now we're going to be what? It's going to be that 30 multiplied by what? 60 minutes. Okay, 60 seconds make 1 minute, right? 60 minutes make 1 hour. So that's how we have this 60. Okay, so convert from hours to seconds. Now we have just minutes alone. 60 seconds make what? 1 minute. So that's why we have what? 1 of the 60 instead of 2. Okay, so let's convert. Let's proceed then. So 2 times let me get my calculator. So we're going to calculate 2 times 60 times 60. What is it going to give to us? 2 times 60 times 60. It gave us 7200 plus, let's see, 30 times 60 gave us what? 1800. Now when we add it up, what is it going to give us? 1800 plus 7200. It gave us what? 9000. That's 900. And what is the unit? Please take note, is what? Seconds, because we just converted these 2 hours 30 minutes to what? Seconds. Do you understand? So I think I have to divide the board. I have to divide the board now, okay? Converted these 2 hours 30 minutes to what? Seconds. So we got 9000 seconds. Okay, so what do we do then? Now from the question, I said the process is what? Electrolysis, right? So meaning while that process was going on, that's the electrolysis of magnesium chloride, something happened. Magnesium ion, okay, was deposited at what? The cathode. okay, at the cathode. So during this process, magnesium ion, let me write it out, Mg2 plus, okay, was deposited at the cathode. Now this is what happened. So we have Mg2 plus, this is ion, plus what, 2 electrons to give us what, magnesium. So this was the process that occurred during what, the electrolysis of magnesium chloride. Now furthermore, what do we do there? So since we've gotten our variables, we have current, we have time. Now we're going to remember that we have Faraday first law of electrolysis, we have Faraday second law of electrolysis. Now looking at this variable here, which of the law fits the question? We have our first law. We're going to use Faraday first law, the first law of electrolysis. Okay, the first law of electrolysis, that's Faraday's first law of electrolysis, states that the mass of a substance deposited or liberated is directly proportional to the quantity of electricity, that's the charge what, that is passing through it. Let me write it up again. So what it means is this, mathematically it means that what, m, that's mass, is directly proportional what, to the quantity of electricity, that's the charge, okay, passing through what, the electrolyte. Do you understand? So now mathematically, when you have a sign of proportionality, what does it mean? You have to what, insert a constant, isn't it? So we're going to have m is equal to what, zq. You understand? And this z simply means what? This z simply means what? Electrochemical what? Equivalence. Okay? Please take note. Electrochemical equivalence. Electrochemical what? Equivalence. Okay, so with this now, please bear with me. I want to use this other part of the board. Okay, let me use this part of the board. Okay, so now we know that m is equal to what? Sorry, I'm trying to, okay, let me divide the board furthermore. So we have what? We know that Q, that's the quantity of electricity, charge, is equal to what? IT. Okay? And now, we're not given the charge, okay, that was passed through. So we have Q is equal to, what's our current given to us as? 2 amperes, right? And what's our time given to us as? When we converted from hours and minutes to what, seconds, we got what? 9,000 seconds. So Q therefore is equal, that's the quantity of charge is equal to what? 2 times 9,000. 9,000 times 2 will give us 18,000. Okay, coulombs. Take note, coulombs. Okay, it's in coulombs. The next step is what? To calculate the moles of electron from Faraday's constant. So what do we do? It's going to be, let me start from here. It's going to be moles of electron, that's from Faraday constant, is equal to what? Is equal to what? Q over F. So what's our Q giving us? 1800. What's Faraday constant given to us as? It was given as what? 9650. So when we divide this, what do we have? So we have 18000 divided by 96500, and that is what? 0.1865. Okay, so this is it now. So we've already gotten what the moles of electron for what, from the Faraday constant. Now what is the next step again? We're going to also calculate what the moles of what? Magnesium. Okay, so we're going to calculate the moles of magnesium. We're going to calculate the moles of magnesium. So we're going to calculate what? The moles of magnesium, okay? So to calculate the moles of magnesium, moles of magnesium and then when you take note during electrolysis I explained what happened, that magnesium was chloride was electrolyzed went through electrolysis, and magnesium was deposited at the cathode, and it emitted 2 electrons. It has a charge of 2 plus, right? So with this now, the moles of magnesium is going to be what this the moles of electron working from Faraday constant, that's 0.1865 divided by 2, this 2 electron, that's this E here, electron, okay, by 2 to give us 0.1865 divided by 2 will give us what? 0.09325. Okay, so now this is not the final answer to the question. The question says, what mass of magnesium, take note, what mass of magnesium, and already we are given that magnesium is what? Equals to 24. Okay, 24, that's the atomic number. So therefore, with these moles of magnesium given to us, we're going to multiply it by the atomic number to give us what? The mass of what? Magnesium. So therefore, the mass of magnesium is equal to what? 0.09325 times what? 24. And let's see what it's going to give us. 0.09325 times 24 to give us what? 2.238 what? Grams. So this is our final answer. So from the options given to us, it says what? A, 1.12 grams, B, 1.80 grams, C, 4.48 grams, D, 2.26 grams. So what is the answer? The answer is what? 2.2 what? 2.238 grams. So approximately this is what our answer. Okay, 2 points. Okay, this is our answer. Sorry. So D here is the answer. Okay. The oxidation states of nitrogen in ammonium nitrite is what? A, +5 or -3, B, -3, C, -3 or +3, D, -3 +5. So what do we do in this state? You're going to look at the oxidation state of what? Nitrogen. You're looking for nitrogen. That's the oxidation state of nitrogen in ammonium nitrite. Okay, so how do you solve this question? First of all, we're going to look at the chemical combination or the chemical formula of ammonium nitrite. It's 2 words here, ammonium what? Nitrite. So we have ammonium itself is NH4 plus, okay? Nitrite itself, this is ammonium, okay? Ammonium, and nitrite is NO2 minus, okay? So this is nitrite. Okay, so we'll combine it together. It's going to give us what? Ammonium nitrite. That's what? NH4NO2. Okay, so this is what? Ammonium nitrite. Now we are asked to look for what? The oxidation states of nitrogen in each of them. So meaning for this chemical compound, we're going to look for what? Nitrogen. We're looking for nitrogen here. So in this compound, so we have NH4 plus. Take note. So what do you do? In this case, you're looking for what? N here, nitrogen. So we're going to make it what? As S. Let S represent what? Rep nitrogen. Mathematically. So therefore, we are going to do what? X plus. Take note. Wait. Okay. 4. Now the oxidation state of of hydrogen is what? +1, except in what? Peroxide, where it is what? -1. That's peroxide. For example, is H2O2. Okay, this is called hydrogen peroxide. This is called hydrogen peroxide. Okay. So in peroxide, hydrogen is what? -2. That's the oxidation state of what? Hydrogen. But in normal cases is what? +1. So we are looking at their oxidation states now. So this is 4 subscript, okay, of hydrogen. So we have 4 into hydrogen, that's +1, is equal to, please take note, whenever you see plus, it means what? It is 1. You know, mathematically, you don't write, for instance, you have x1 plus x1 to give us this is mathematically wrong, okay? So instead, just take what? Just the x alone. It's going to give us what? 2x. So the same thing applies to this, okay? So what do we do then? So because this plus sign, this is a radical, okay? It's a radical, so it's going to be what? +1 because of this n here. Assuming it was 2 plus, it would have been what? +2. Do you understand? But since it's just +1, okay, that's the ion, okay? So that's plus. So it's going to be what? +1. So what do we do then? We have x plus 4 times 1 is what? So let me just move this plus sign, okay, for teaching sake, okay? Just note this +1. So let me just move this sign here so that, or let me leave it so you understand better. So we have 4 into what? 1 is equal to what? 1. I'm just trying to remove this plus sign already. So we have x plus 4 times 1 is what? 4, right? Equal to 1. So we have x. Now, for us to get our nitrogen, what do we do? This 1 here, 4 will cross over this equals to sign to give us what? A minus sign. This +4 here, okay? The +4 will cross over, it will become what? Minus. So we have 1 minus 4. So x, therefore 1 minus 4 is equal to what? -3, okay? So the oxidation state of nitrogen in ammonium is what? -3. So let's calculate the oxidation state of nitrogen in nitrite, okay? So this is the formula. We have NO2-. So what do? We make S the same thing. Let S represent what? N. Do you understand? That's nitrogen, okay? So we have X plus 2 into, and take note, the oxidation state of oxygen is what? -2, okay? -2 is equal to, and I said something here, because this minus sign at the top, this is a radical, it's going to be what? -1. Take note. If it's -2 here, it will have been what? -2. You understand, okay? So let's proceed then. X plus, okay, you know, let's open the bracket. +2 minus 2. Sorry. +2 times, okay, let me just make it more elaborate. So okay, we have plus, okay? So 2 times -2 is what? -4, okay? Is equal to what? -1. So let's open the bracket. Is minus, so you have -4 is equal to what? -1. So we have x is equal to what? This -4 will cross over to this point to give us what? Plus. So we have x is equal to -1 plus 4. S is equal to what? +3. You understand? So therefore, the duster. Okay. So therefore, the oxidation state of nitrogen in ammonium nitrite is what? -3 and +3. That's -3 and +3. That's C is equal to what? Our answer. Thank you very much and bye.